LLM-generated context files made things worse. A blog post just dropped breaking down the first rigorous study on whether agents.md files actually help your coding agents. They tested Claude Code, Codex, and Qwen code across hundreds of real tasks. TLDR, auto-generated context files cost more and solve less. And handwritten ones, on average, barely move the needle. I'm going to walk you through the findings and then show you exactly what works to make your agents.md file truly valuable. Shout out to JP at the Sulot Substack. He writes, the research is in, your agents.md might be hurting you. Over 60,000 public GitHub repos now include some form of context file for coding agents. Agents.md, CLAUDE.md, those of course are the big ones. The premise is the same. Give your AI coding assistant a cheat sheet about your project and it'll do better work. Every major agent framework supports it. Every AI coding tool has a /init command that generates one. The convention spread the way most developer conventions spread. Someone influential did it, someone else copied it, and within 6 months, it was table stakes. Nobody stopped to measure whether it actually helped. Then, in February 2026, a team at ETH Zurich, a research institute in Switzerland, did exactly that. My Swiss is terrible, so apologies. The team built something called AGENTBench, 138 task instances drawn from 12 real repositories that already had developer-written context files, sourced from nearly 5,700 pull requests. They also ran experiments on SWE-bench Lite, the existing standard benchmark. 4 coding agents got the treatment. Claude Code with Sonnet 4.5, Codex with GPT 5.2 and GPT 5.1 mini, and Qwen Code with Qwen 3. Each ran under 3 conditions: no context file at all, an LLM-generated context file, and a human-written context file. LLM-generated context files made things worse. Performance dropped in 5 out of 8 experimental settings, with an average decline of around 2% on AGENTBench, and the cost up to 20 to 23%. LLM-generated context files made things worse. Human-written files did slightly better, averaging a 4% improvement. But average hides a lot. Claude Code actually performed worse with human-written context files than with none at all. The improvement was inconsistent across agents and benchmarks. Sometimes it helped, sometimes it didn't, and you couldn't predict which. And context files didn't help agents find the right files any faster. The researchers tracked file discovery rates across all conditions, and the curves were essentially identical. Then there's the reasoning cost. GPT 5.2 spent 22% more reasoning tokens when given a context file. GPT 5.1 mini spent 14% more. And every single context file generated by Sonnet 4.5 was flagged for containing a code-based overview. 100%. The model couldn't resist explaining the repo's architecture back to itself. Another study found the opposite. Lola et al., published a month earlier, tested human-authored agents.md files on 124 real GitHub pull requests and found roughly a 29% reduction in median runtime and 17% fewer output tokens. But the two teams measured different things. Lola et al. Measured efficiency, how quickly agents navigate a codebase and how many tokens they burn doing it. The Swiss team measured correctness, whether agents actually solve the task. So why do the context files backfire? There are 3 failure mechanisms proposed for why context files backfire: redundancy, attention, and anchoring. The redundancy problem. When LLMs generate context files, they produce information the agent would discover anyway by reading the code. It's duplication, not augmentation. The attention tax. Liu et al. Demonstrated that LLMs exhibit U-shaped attention. They attend strongly to the beginning and end of their context window and poorly to the middle. The anchoring trap. Agents follow instructions faithfully, sometimes too faithfully. The ETH Zurich data shows that when a context file mentions UV, agents use it 1.6 times per task instance versus less than 0.01 times when it's not mentioned. Repo-specific tools jump from 0.05 to 2.5 times. That sounds great until you realize it also means agents anchor on whatever the context file says, even when the instructions are outdated or wrong. Adi Osmani from Google synthesized the findings into a practical filter that's worth memorizing. Can the agent discover this on its own by reading your code? If yes, delete it. Here's what you should include. Tool preferences like UV, not pip. Test quirks like use no cache, legacy traps, and custom middleware warnings. What you should omit is code-based structure, language and framework, directory tree, and tech stack overview. As Osmani puts it, Coding agents aren't new hires. They can grep the entire code base before you finish typing your prompt. What they need isn't a map. They need to know where the landmines are. Start with an almost empty file. Run the agent on real tasks. When it trips on something non-obvious, add one line. When you fix the root cause of a friction point, delete the line. The context file becomes a living list of active hazards, not a static encyclopedia. This is an interesting section here because it goes over people who are working on solutions that don't rely on a single static file. The ACE framework, Agentic Context Engineering, uses a generator reflector curator pipeline to build task-specific context on the fly. Instead of one file for all situations, it generates relevant context per task and outperforms static approaches by 12.3%. Separately, Arise AI's optimization loop takes a different angle. Run the agent on a set of training tasks, evaluate the results, generate LLM feedback on what went wrong, refine the instructions, repeat. Their results showed roughly 5% accuracy gains on cross-repo tasks and 11% on in-repo tasks. Osmani proposes a layered architecture, a protocol file that routes to a focus persona or skill files loaded per task, with a maintenance sub-agent that keeps everything current. The useful version of AGENTS.md is short, human-written, focused on the things code can't tell you, updated when reality changes, and pruned when problems get fixed. The main takeaway is that you need to strip your context file down to the stuff that your code can't tell the agent on its own. And if you watch my Vercel video, this is interesting because that study showed agents.md files crushing it. But the key difference is what they put in it. A compressed docs index that made sure the agent never had to decide whether to go look up information. It was just there. It's the same conclusion from a different angle. It's not about more context, it's about the right context. If you made it this far, please like, subscribe, and share. It helps us out so much. There is a lot more coming. I'll see you next time.